Today we want to talk about fractions. Fractions seem to be complicated sometimes. When we slow down, take a look at what they really are, they're not that hard at all. The first way we want to look at fractions today is that fractions are part of a whole. Let's take a look at these three wholes that I've drawn here. If I'm looking at this piece and I divide it into two segments, I know that each segment is 1/2. 1/2 is part of a whole. Together, these two halves equal one whole. If I look at this one, again, it's a whole piece. If I divide it into three segments, each segment is 1/3. Together, the 1, 2, 3 thirds, they will equal one whole. Again, we're talking about fractions being part of a whole, representing part of a whole. If we look at this one, divide it into 4 equal sections. Each section would then be worth 1/4. Together, those 4/4 equal one whole. Fractions are going to show us parts of a whole. That's one way we're going to look at fractions today. All right, we're continuing to talk about fractions. Fractions show us lots of things. Parts of a whole, parts of a group, and division, all wrapped up in one. Fractions have special names for their parts, though. The top number we call the numerator. The bottom number we call the denominator. If I'm looking at this representation of a fraction, this drawing, I have 2 out of 3 pieces shaded. So this fraction would be 2/3. The numerator is 2. It shows us how many pieces are shaded. The denominator is 3. And it shows me how many equal parts I've divided the whole into. The way I like to think about it is the numerator is the number of pieces we're working with, and the denominator shows me how many pieces the whole part is, or how many pieces the whole part's been divided into. So if this were a pizza, it would have been divided into 3 pieces, and Mr. Pratt would have eaten, well, 2 of them. It's just how I am. So thinking about that, fractions are going to show us those things. The numerator is the top number, shows us how many pieces we're working with. The denominator is the bottom number. It shows us how many parts of the whole we've divided. Numerator and denominator. As we're talking about fractions being parts of a whole, we can use a couple of diagrams here to kind of show us that illustration in that example. Here we see a box divided into 6 relatively equal-sized pieces. We see that 2/6 are blue, 3/6 are orange, and 1/6 is green. The box is completely filled with color, so we can see that all of these added up together, the sum of all of the fractions came up to one whole. That's showing us that each part is part of that whole. 2/6 plus 3/6 plus 1/6 equals 6/6, which equals 1, or one whole. We see the same here. Here we have a box divided into 8 equal parts. 1/6 is blue. 1, 2, 3/6. I'm sorry. These are 8s. 8 equal parts, my mistake. 1/8 is blue. 1, 2, 3/8 is red. 2/8 are orange. And 2 more 8s are green. Now we can see that each one of these pieces helps fill up the entire space, completes the whole. So here, 1 plus 2, or 1 plus 3 is 4, plus 2 is 6, plus 2 is 8. So we have 8/8, which equals 1 whole. Fractions are representing parts of an entire whole. Keeping in mind that fractions make up parts of a whole, if I have 2/8 of something that's blue, 2/8 that's orange, 1/8 that is green, and I want to color in the rest of this red, how many 8s will I have to finish out to make red? Well, we can see from the illustration here very plainly that it's going to be 3/8. But how will that look mathematically? Well, I know that I have to add something else here to equal 8/8 to make my whole. Well, 2 plus 2 is 4/8 plus 5/8, or 1/8 would be 5/8. So 5/8 plus some number of 8s that I'm not sure about yet will equal 8/8, or 1 whole. Well, 8 minus 5 would mean 3/8. Again, I can see that from the illustration, but this is how it would work mathematically. 2/8 plus 2/8 plus 1/8 is 5/8. Well, 5/8 plus something is going to equal 8/8. 5/8 plus 3/8 gives me the 8/8 that I need to make a whole. So I would color the rest of this red, and that would be 3/8 to color red. Fractions not only show us parts of a whole, but they can also show us division. If we're looking at this is just a really simple example. 1 divided by 8. So I've got 1 whole here. And I want to divide that 1 whole into 8 equal pieces. Well, if I were to do that, each piece represents 1/8 of that whole. So 1 divided by 8 would equal 1/8. Now this one's a little more interesting. What if I have 3 divided by 4? Okay. So I'm going to divide these 3 wholes each into 4 separate groups. So I've done that. Each whole is now divided into 4 equal groups. Each piece represents 1/4 of 1 whole. So 3 divided by 4, well, right here I see there's 3 groups, each divided by 4. 1, 2, 3. My answer is going to be 3/4. 3 divided by 4 equals 3/4. Now, another way we talked about this, when we talked about division, we talked about how we can write division problems as a fraction. We see 1 divided by 8. Well, we see the same thing in a fraction. 1 divided by 8. 3 divided by 4, 3 divided by 4. So fractions not only can represent parts of a whole, they can also represent division. Fractions can also be used to represent parts of a group, like we see here. Here I have 18 magnetic tiles. I see 1, 2, 3, 4, 5, 6. 6 out of those 18 are purple, and then 12 out of the 18 are red. But I could also look at these same fractions and say, 1/3 of that group is purple, or 2/3 of the same group is red. So fractions can represent parts of a whole, division, or part of a group of things, or several numbers of items. So we're going to look at fractions in all different ways as we start to continue on our study of fractions through here. Fractions can be parts of a whole, parts of a group like we're seeing here, or can represent division like we've seen earlier. Something else about fractions is that fractions can be equivalent fractions, meaning that they can be equal to one another. The way I like to think about equivalent fractions is that equivalent fractions have the same value but may have different names. I'm looking at these 3 examples of equivalent fractions. Here I see a whole divided into 3 equal parts. 2 are shaded blue. This fraction is 2/3. Well, here I see another whole divided into 6 equal parts. 4 are shaded blue. This fraction would be 4/6. But when I look, 2/3 is covering the same amount of space as 4/6. 2/3 and 4/6 have the same value, they just have different names. So I could say that 2/3 is equal to 4/6, meaning that they are equivalent fractions. Well, I look down at this one, I have yet another whole. This one's divided into 12 equal pieces. 1, 2, 3, 4, 5, 6, 7, 8. 8/12 are colored blue. Okay. Well, but when I look, again, 4/6 has the same amount of blue as 8/12. So I could say that 4/6 is equal to 8/12. So 4/6 is equivalent to 8/12, or 4/6 and 8/12 are equivalent fractions. But because 4/6 is equivalent to 2/3, and I look at my picture to confirm this, yeah, 2/3 of a fraction is showing as much blue as 8/12, and I can also say that 8/12 is equal to 2/3, and 8/12 and 2/3 are equivalent fractions. Equivalent fractions are fractions that have the same value, but use different names to describe them. Same value, different names. Showing here, 2/3 is equal to 4/6, which is equal to 8/12. All of these are equivalent fractions.